All right, I wanted to cover a few extra things about volume. Hopefully this will be fast. The first is something that is, I've always heard it referred to as Cavalier's principle. I don't know where it comes from, but it's pretty simple. It's kind of neat, really. If two space figures, that's a weird phrase, but like three-dimensional figures, have the same height and the same cross-sectional area. So cross-section is if you slice it across. This has a square cross-section. This has a, I guess this would technically be a parallelogram. And this would be a triangular cross-section. If those areas are the same and they're the same height, then they'll have the same volume. The most simple is simply like a cylinder versus like a curvy or slanty cylinder. These should hold the same amount because they're made up of the same cross-sections. Okay, cool. Well, that just means that, well, now, even if you had a slanty prism, this would be a prism, even if you had a slanty prism, you'd still find the area the same way, or the volume the same way, length times width times height, or area of the base, which would just be this thing, times the height. But not like this height. That's what we're going to call the slant height, the from here to here height. So kind of a neat little problem. If these prisms are the same height and they are the same volume, then what's missing? Well, in this problem, if they're the same height and the same volume, then we have kind of the other order here, that the cross-sectional area must be the same. So that means this square, which is a square, so it's a 3 by 3, and this parallelogram. Well, parallelogram is area is base times height, and they're saying the height is 3. Well, that means this base must also be 3. But now this would be 1/2 3 times x, if this was x, and that has to equal the same as both of these, which are 9, because they're 3 times 3. 9 is that area. And so 1/2 3 times what? Well, I could just move that over, and eventually I just get 6. So 6 centimeters. So kind of a neat little thing. Mostly I want to introduce you to that because at least one on our worksheet has, like, it's slanty. But the idea is you could just use the same formula as long as you know the height, which is this, the height is simply how far it is between the two parallel bases. It actually would work even for cones and prisms and, or yeah, pyramids is what I meant to say. Which, to the next one, what's the volume of this square pyramid? You've already done this, and hopefully the video kind of helped you make sense of why it is what it is. But a pyramid or a cone is simply 1/3 the volume of the shape as if it were just a prism, as if you just connected the dots. And the idea basically is that 3 of these pyramids could fit into the prism that would surround it. So the prism would be like if you just made this a box that had the same height. So that pyramid should be 1/3 of that prism. Okay, oops. We know that. But I wanted to show you a new problem that I don't think you saw at all. I didn't do every single delta math, but I don't think you had them here, where you're given a slant height. Let me just read it. Sometimes the height of a triangular face of a pyramid is not given. That's what we need. We need the height. But here we have a slant height given. Use what you know about right triangles to find what's missing and then find the volume. Okay, because the idea here is I would need the line that comes straight down to like the center. That's the height. How tall is this? That's what I need. X, or maybe I should call it H, whatever. Well, because then it would be, so the volume should be 1/3 the area of the base, which is a 14 by 14 rectangle, also called a square, times the height. But I don't know the height. So 1/3 14 times 14 times h. So now we have a little mini problem. How do I find the height? Well, it gave us a hint. Use what I know about right triangles. Ah, they're 90 degrees. That's not helpful. SOHCAHTOA? Maybe. How about Pythagorean theorem? Oh, yeah, there we go. So the idea is I need to take this just little triangle. So I'm going to take this green triangle, which has my height, and this slant height. That is a right triangle because your height just goes straight up. That right triangle, drawn like this, has this is what I need, the height. But I know this is 25 because that's what they told me. And then what is this other one? Well, this is not 14, this is half of 14, so this is 7. And now Pythagorean theorem, or I just know this one, 7, 24, 25. To get that, I do 25 squared is 7 squared plus h squared. But you can just take my word for it, it's going to be 24, because this is one of the 3, 4, 5, 5, 12, 13, 7, 24, 25. Some of the more common Pythagorean triples. Okay, so once I get that 24, then I just plug it in here, and then just multiply all that out, which I think we could do in our head, maybe. Because, so let me just practice tricks, right? 1/3 of 24 is 8. 14 squared, I like to go 10 times 18 is 180. So this is 14. So if I go down 4 to the nearest 10 and up 4, and then I just tack on a 4 squared, so 196. I actually knew that one, but that's a cool trick. And now, how do you multiply these? Could we try left to right, like mental math is a little tricky, but so this would give me an 8, this would give me a 72, and this would give me a 48. So 8, 6, 15, 1568, something cubed. What are these? Centimeters cubed. I might have messed that up, but I'm just going to go with it. Main point here and here. What's the volume of the cone? Oh, simple. It is a cone, so it's 1/3 the base times the height. In this case, the base is a circle, so pi r squared, and they told me 5, so 25, 5 squared pi, times a third. Okay, now I just need the height, 13? No. 13. H is the height. Oh, well, this is just a 5, 12, 13, because 5 squared plus h squared is 13 squared, which equals 144, so h is 12. And so, times 12. So I just wanted to add a couple examples of this, a little quick recap. That way you are equipped to do all of this new worksheet. So, just practicing. So Cavalier's principle here. So the idea here is the volume of that. It's still just pi r squared h, but in this case h is the x because it's slanty, and you're given the volume. So you'll just this one, number 5, is not very clear. This is supposed to be like a half a cylinder tacked on here. I don't know why they drew it weird. I feel like it should have been. I don't know. I feel like it should have been drawn differently, like more like that or something. I don't know. That's supposed to be a half a cylinder though, which is just half of pi r squared h kind of thing. That's a cool problem. That one's a little tricky, but I think you can get it. And then some of these, at least one, is going to need kind of what we were just doing, like this one here. This one here, you don't know this x, so you'll have to use this. This is like a right triangle here, which is just a 3, 4, 5. Oh, I'm saying the answers. Shoot. And then also we didn't cover what's the surface area of a sphere, so that's what that other video was. It's just a simple formula. So, all right, so hopefully that practice goes great today.